Newton's third law. It says simply when one body acts on another, then the second body acts back on the first with an equal and opposite force. So, simple example. I'm leaning on the desk. Why aren't I falling over? What's stopping me falling over? The desk. So, as I push on the desk is pushing on me. There's an equal and opposite force. I'm pushing on the desk is pushing on me, and it's stopping me fall over. Now, slightly vary it on the same theme. I'm going to push on the desk. I push on the desk, and off I go. Why did I accelerate? Why did I accelerate? So the response, or the acceleration, comes from the Newton's third law paired. I'm pushing on the desk pushes on me, and that's why I moved away. Okay. Why did the balloon accelerate? There's a force involved. It accelerated, right? That means there's a force on the balloon. Where did the force come from? There's a Newton's third law thing going down here. Here's the balloon. It doesn't matter what's outside, it's full of air. But because of the pressure of the balloon, the elastic force of the air, the balloon pushes air out. That's one force in this process. There is a Newton's third law force that acts in the other way. The air that's being expelled pushes on the balloon, which means the balloon accelerates. So it's the act of throwing stuff out the back, pushing stuff out, that causes the stuff that's pushed out, the Newton's third law, other force, pushes back on the balloon and accelerates it. What I've got here is a simple plastic bottle, but if you look on the outside, there's a couple of vents that are angled backwards. If you have a look closer, you can see the vents. I'm going to fill it with liquid nitrogen and boil it. So, liquid nitrogen. As I say, one of the neat things about being a physicist is you get to play with some really fun toys. And this is liquid nitrogen, which is one of the more fun ones. It's about a couple of 100 degrees below zero. Now, I should probably need the... So what I've got is I've got a boiling liquid. Hero did this with steam. I'm going to do it with liquid nitrogen. And I'm going to warm up the liquid nitrogen by putting in, this is just ordinary water. And we get this wonderful little jet engine. So what's happening? There's high pressure in here. The pressure forces, let's warm it up again. The pressure inside forces the gas out, and the Newton's third law reaction force pushes the cylinder in the opposite direction, causing it to spin. There's a force of this plastic bottle on the gas going out, and there's a Newton's law force of the gas on the bottle spinning it in the other direction. And I have a jet engine here. Now, this is not an ordinary fire extinguisher. Every single reduction valve has been removed from this thing, so it's a fairly lethal fire extinguisher. When I crack the valve, it will empty itself in about 10 seconds. And I'm going to sit on the skateboard, hold on to this thing, crack the valve, and hopefully I will hurtle along behind the building. There's a huge force of the cylinder on the gas. And then that gas pushes back on the cylinder and on me, accelerating me. So, 4, 3, 2,